Hi, I'm Sanjay Uppal and I run the VeloCloud Division at Broadcom. I'm really excited to talk about what's coming next in the space of networking, more specifically enterprise wide area networking. Now, what's happened over the course of the last decade or so, SD-WAN started in phase one and it became very successful because enterprise applications were moving to the cloud and the internet was becoming good enough to run from an enterprise networking standpoint. So VeloCloud stepped in with a few other folks as well and came up with this really simple way of setting up an enterprise network, a secure network, and optimized network to take care of these applications that are moving to the cloud and the various networking technologies that were becoming available, aka the internet, so that you could run an enterprise network. Telecom operators took advantage of this because they could come in, take the SD-WAN service, attach it to the underlying network, and provide it as a service to enterprises. That was phase one of SD-WAN. Then, of course, concerns about security came up, and we came up with our security enabled connectivity for SD-WAN, which the overall industry called SASE, for Secure Access Services Edge. And now we are at the advent of what's the third phase of what's going on in this revolution in networking. And this third phase is what I want to talk about today. This third phase is about AI networking. More specifically, what is Gen AI going to do to enterprise networks and therefore also to the telco networks? Now, one would say, what's different? Why is it that this third phase is about Gen AI? And the reason that it is different is because Gen AI workloads are very different from the workloads that we are used to seeing today. And they're different from a number of perspectives. The first thing we know, of course, is that web applications are asymmetric. There's a lot more downstream traffic than upstream. When you ask a question or you type in something into a search, whether it's an enterprise application or consumer application, small amounts of information go upstream and then you get a response back. And the response is video, audio, large quantities of text. Gen AI is almost exactly the opposite. You have multimodality, meaning that you send a lot of multimodal data upstream, which could be voice, video, text, and then you get answers back downstream, which could be short or long. So this is one reason why there's asymmetry. Just consider someone uploading a piece of video and then asking the large language model, tell me what's the most important part of this video. It used to be, it would cost about $100 to process an hour of video. It's almost down to 10 cents. So when that kind of breakthrough happens in terms of costing, we know that this results in changes in even human behavior. So we expect a lot more multimodality. We expect a lot more traffic to go from the edges of an enterprise all the way up into the small language or the large language models, and small responses come down. In fact, in many cases, I have seen almost 100 to 1 asymmetry in the opposite direction. 100 times more information going upstream than coming downstream. So this is the first part. The second part is the change in traffic because of RAG, retrieval augmented generation, because these large language models that take hundreds of millions of dollars to train, they don't have the most recent information, and they also don't have your proprietary enterprise information. So when you take this proprietary information, what you're doing is from the edges of an enterprise, you're uploading this information into the large language models. When you do that, there's of course a lot of asymmetry because there's large quantities of enterprise information and even more quantities that are being generated outside of the data center. In fact, in the last few years, more traffic is generated outside of the data center than inside of the data center. Now consider all of that traffic being used to fine-train or pre-train these large language models. So this is the second reason why the traffic is asymmetric. And the third reason, and probably the most important reason, is because of agentic AI. So what's happening right now is because of the advent of agents, we're finding that Gen AI workloads are going to be comprised of large language models, small language models dispersed around both the public network as well as the private network, fronted by agents. These agents will talk to each other in a peer-to-peer relationship. So you have peer-to-peer behavior, you have latency that needs to be short because people expect responses back in a particular time frame, regardless of whether it's retail, manufacturing, health, any one of these considerations. And then you have this multimodality that is going on. All of this means Gen AI workloads are going to be very different, and we are already seeing this in measurements that we're doing today. Now, when you look at what's happening in 2025 and beyond, most enterprises have Gen AI projects that they are launching. Those Gen AI projects are going to have a requirement on the network. And if the network is not ready, then the Gen AI projects are not going to be successful. So what we are saying is, if you, the enterprise or a telecom operator, you have Gen AI projects that you're either contributing to or launching yourselves, make sure that there's a line item in the budget that says AI networking, because that will make your Gen AI project be successful going into the future. Now, what we are doing from a VeloCloud standpoint is we are getting ready for this. We've launched an architecture for AI networking called VeloRAIN. RAIN stands for Robust AI Networking. So VeloRAIN, and what VeloRAIN does, the first thing is you've got to identify the application. If you identify the application, then you can make decisions based on optimization, based on security for that application. So we are using AI techniques to identify applications, even as more and more applications are becoming encrypted. Even the initial handshake is getting encrypted. So we have to use AI techniques to identify the app. Once the app is identified, then we do channel estimation. Channel estimation meaning some of these new channels, by channel I mean the underlay, 5G or satellite, are much more variable than the wired connections. So when you look at the variability of bandwidth, packet loss, jitter, and latency, you can't keep probing the underlay to ask it what the channel looks like. But you can do channel estimation, and in some cases you can even get hints from the underlay as to what that channel is. So you know the app, you know how the channel is behaving. Now you can make a business decision about which app to send over what network and what quality of service. And this quality of service angle, or even quality of experience for the end user, is what we're calling as dynamic application based slicing, or DABS for short. And this DABS is very important because regardless of whether there's a slice in the underlay on 5G or whichever underlay you have, what the enterprise is concerned with is what's the application layer slice. So what's the quality of experience for that specific application for the period of time that the application needs it, or for the period of time that the human user needs it. So when you set up this application-based slice, you, the telecom operator, can charge more for that slice. It is not nailed down into a physical network. It's not nailed down to a SIM. It's not nailed down to an ASN. It's actually an application-based slice that you can send end to end. And the last piece of this is about security. Because of Gen AI, there's a lot of traffic that is leaving the enterprise. You've got to be able to secure the places that it's leaving from. So that's kind of securing the edge. You've got to be able to secure the traffic as it's in motion, reduce the attack surface by using segmentation, which we know how to do very well in SD-WAN, and then be able to crack open only certain streams of that traffic in the cloud so that we can apply the principles of CASB as well as secure web gateway so we can secure the traffic itself. So when you put it all together, I just want to give you an example. A shopper walks into the store. That shopper happens to have a pair of these glasses. These are the Ray-Ban Meta glasses. This is the fastest selling product in the store today, as I hear. And when they walk into the store, they look at a wall and they're looking at products, both physical and virtual. And in the upstream direction, there's a video. There's both image as well as video capture. And that video is then sent to a large or small language model in the back end to get you a response that comes in audio. So you have 100 times more traffic in the upstream direction than in the downstream. But as the shopper is walking around the store, they're getting real-time feedback on the products that they're looking at. And that real-time feedback allows them to make an intelligent shopping decision. And they can interact with the glasses that they have, and they can have these real-time conversations, and then they're thrown maybe a loyalty coupon, and they make a purchase and leave the store. This is just one example. It's a consumer example, but many examples abound because we're actually looking at a phase now where it's not just going to be your smartphones or other devices. The number of intelligent devices with which Gen AI, SLMs, and LLMs will interact in this peer-to-peer nature is just going to explode. There are any number of enterprise use cases that are available as well. So just to wrap up, I couldn't be more excited about this third phase of what SD-WAN is bringing and what we as VeloCloud can bring to the entire industry, the combination of network optimization and security with an absolutely simplified way of running the network for you, the telecom operator, but also in turn, you, the enterprise, so that your GenAI projects can be successful in 2025. Thank you.